The M4 Sherman medium tank was the backbone of the United States Army and its allies during World War II. Designed for mass production, mechanical reliability, and battlefield flexibility, the Sherman became the most widely used Allied tank of the war. While it was not always the most powerful tank on the battlefield, its true strength came from numbers, logistics, and adaptability. Development of the M4 Sherman began in 1941 as the USA Army sought a modern medium tank to replace earlier designs like the M3 Lee. Engineers prioritized ease of manufacturing and maintenance, knowing that a global war would require tens of thousands of armored vehicles. The result was a tank that could be produced quickly in multiple factories across the United States. The Sherman was powered by several different engines depending on the variant, including gasoline radial engines and later diesel versions for Allied forces. This flexibility allowed production to continue even when specific engines were in short supply. The tank's vertical volute spring suspension provided reasonable mobility across varied terrain, from the deserts of North Africa to the muddy fields of Europe. Early Shermans were armed with a 75 mm gun, effective against infantry positions, bunkers, and early war enemy armor. As the war progressed and German tanks became more heavily armored, later Sherman variants received a more powerful 76 mm gun and improved armor protection. Specialized versions also appeared, including flamethrower tanks, bulldozer tanks, and rocket-equipped assault vehicles. One of the Sherman's greatest advantages was reliability. While German tanks like the Panther and Tiger were powerful, they often suffered from mechanical failures. Shermans, by contrast, could travel long distances with fewer breakdowns and could be repaired quickly in the field. This reliability allowed US-5 armored units to maintain constant pressure on enemy forces. The Sherman saw combat in nearly every theater of World War II. In North Africa, it helped Allied forces defeat Axis armor. In Italy, it supported infantry through difficult mountainous terrain. After D-Day, thousands of Shermans rolled across Western Europe, forming the armored spearhead of the Allied advance into Germany. Although criticized for thinner armor compared to German heavy tanks, the Sherman was never intended to fight alone. USA doctrine emphasized combined arms warfare, where tanks operated alongside infantry, artillery, air support, and tank destroyers. In this role, the Sherman proved highly effective. By the end of the war, more than 49,000 M4 Shermans had been built. Its legacy continued long after 1945, serving in numerous post-war conflicts around the world. The Sherman remains one of the most iconic tanks in military history, symbolizing American industrial power and battlefield adaptability. The M3 Lee, known as the M3 Grant in British service, was an unusual but important American tank developed during the early years of World War II. At a time when the United States urgently needed a medium tank, the M3 provided a rapid solution, while more advanced designs were still under development. Introduced in 1941, the M3 Lee featured a distinctive design with its main 75 mm gun mounted in a side spunson rather than a rotating turret. This arrangement was not ideal but allowed the U.S. Army to field a tank with a powerful gun much faster than waiting for a fully turreted design. A smaller turret mounted on top housed a 37 mm gun for engaging lighter targets. The M3 was heavily armed for its time, capable of firing both high-explosive and armor-piercing shells. This made it particularly effective against enemy fortifications and early German tanks. However, its tall profile made it more visible on the battlefield, and its limited gun traverse required careful positioning during combat. Despite its flaws, the M3 Lee played a critical role in the North African campaign. When Allied forces faced German armor in 1942, the M3's 75 mm gun finally gave them a weapon capable of challenging Axis tanks at longer ranges. British forces, who called their version the Grant, used it extensively until more advanced tanks became available. The M3 was powered by a radial aircraft engine, giving it decent speed and reliability. Its armor protection was respectable for the period, though it lacked the sloped armor that would later become standard. Crews often appreciated the tank's firepower, but criticized its cramped interior and awkward layout. The M3 Lee also served as a stepping stone in American tank design. Lessons learned from its combat use directly influenced the development of the M4 Sherman. Engineers gained valuable experience in mass production, crew ergonomics, and battlefield requirements. Although the M3 was eventually replaced by the Sherman, it continued to serve in secondary roles throughout the war. Some were converted into recovery vehicles, command tanks, or training platforms. While often overshadowed by later tanks, the M3 Lee was a vital emergency solution during a critical moment in the war. Without it, Allied armored forces would have faced the enemy with far less effective equipment during the early campaigns. The M24 Chaffee light tank was one of the most advanced light tanks of World War II and represented a major leap forward in reconnaissance and fast-moving armored warfare. Designed to replace earlier light tanks, the Chaffee combined speed, firepower, and improved crew comfort into a highly effective battlefield vehicle. Introduced in late 1944, the M24 was armed with a 75 mm gun, an impressive weapon for a light tank. This gun gave the Chaffee enough firepower to engage enemy light and medium vehicles while still maintaining its primary role as a reconnaissance platform. One of the Chaffee's greatest strengths was mobility. Powered by twin Cadillac engines and equipped with a torsion bar suspension, it offered smooth handling and high speed across rough terrain. This made it ideal for scouting missions, flanking maneuvers, and rapid exploitation of breakthroughs. Unlike earlier light tanks, the M24 emphasized crew survivability and comfort, improved interior layout, better visibility, and reliable mechanical systems reduced crew fatigue and increased battlefield effectiveness. The tank's lower silhouette also made it harder to detect and target. The Chaffee entered combat during the final months of World War II, seeing action in Europe during the Allied push into Germany. It proved especially useful for reconnaissance units, screening advances, and maintaining contact with retreating enemy forces. Although lightly armored, the Chaffee relied on speed rather than protection. Crews were trained to avoid direct engagements with heavy enemy tanks, instead using their mobility to gather intelligence and strike vulnerable targets. After World War II, the M24 Chaffee enjoyed a long service life, participating in conflicts such as the Korean War and serving with numerous countries worldwide. Its design influenced future generations of light tanks and reconnaissance vehicles. The M24 Chaffee demonstrated that light tanks could be more than lightly armed scouts. It combined modern engineering with practical battlefield needs, earning a reputation as one of the finest light tanks of its era. The M26 Pershing heavy tank represented a major turning point in American armored warfare during World War II. Developed late in the war, the Pershing was designed to counter the increasingly powerful German tanks that had begun to dominate the battlefield, such as the Panther and Tiger. Unlike earlier American tanks, the Pershing prioritized firepower and armor over mass production speed. Development of the M26 began as the USB. Army recognized the limitations of the M4 Sherman when facing heavily armored German vehicles. Engineers sought a tank that could survive direct combat with enemy heavy tanks while still maintaining acceptable mobility. The result was a well-balanced design that bridged the gap between medium and heavy tank classifications. The Pershing was armed with a powerful 90 mm gun, capable of penetrating the frontal armor of most German tanks at combat ranges. This gun finally gave American tank crews a weapon that could meet German armor on equal terms. The tank also carried advanced optics and improved fire control systems, increasing accuracy and effectiveness in combat. Armor protection on the M26 was significantly improved compared to earlier U.S. tanks. Sloped frontal armor increased effective thickness without dramatically increasing weight. This design philosophy reflected lessons learned from both Allied and enemy tank designs earlier in the war. Powered by a gasoline engine, the Pershing was slower than the Sherman, but still capable of keeping pace with advancing forces. Its torsion bar suspension provided a smoother ride and better cross-country performance, especially in rough European terrain. The M26 Pershing entered combat in early 1945 during the final stages of the war in Europe. Although its numbers were limited, it quickly proved its value. In several documented engagements, Pershing tanks successfully destroyed German heavy tanks, demonstrating their superiority in firepower and protection. Despite arriving too late to influence the overall outcome of the war, the Pershing had a lasting impact. It formed the basis for post-war American tank development and influenced designs used during the early Cold War period. The M26 Pershing symbolized the evolution of American tank doctrine, from reliance on speed and numbers to a more balanced approach emphasizing firepower, protection, and survivability on the modern battlefield. The M10 Wolverine tank destroyer was a key element of American anti-armor strategy during World War II. Unlike traditional tanks, the M10 was designed specifically to hunt and destroy enemy armored vehicles using speed, firepower, and tactical positioning rather than heavy armor. Introduced in 1942, the M10 was built on a modified tank chassis and featured an open-top turret. This design reduced weight and improved visibility for the crew, though it also left them vulnerable to artillery and small arms fire from above. Despite this risk, the open turret allowed excellent observation and faster target acquisition. The Wolverine was armed with a 3-inch gun capable of defeating most German tanks encountered during the mid-war period. Its high-velocity rounds made it especially effective in ambush roles, where it could strike enemy armor from concealed positions. American tank destroyer doctrine emphasized mobility and surprise, and 10 units were trained to move quickly to threaten sectors, set up defensive ambushes, and eliminate enemy armored breakthroughs. The Wolverine's speed and maneuverability made it well suited for this role. The M10 saw extensive combat in North Africa, Italy, and Western Europe. It played a significant role during the Normandy campaign and the Battle of the Bulge, where tank destroyer units were often called upon to halt German counterattacks. One limitation of the M10 was its relatively thin armor, which required careful tactical use. Crews relied on teamwork, terrain, and coordination with infantry and artillery to survive. In many cases, the M10 proved highly effective when used according to doctrine. The M10 Wolverine also served with Allied nations, including Britain and France, further extending its impact on the war. Some Allied versions were even modified with more powerful guns to improve performance against late-war German armor. Although later replaced by more advanced tank destroyers, the M10 Wolverine remains an important symbol of American adaptability and specialized armored warfare during World War II. The M18 Hellcat tank destroyer was the fastest armored fighting vehicle fielded by the United States during World War II. Designed for speed and aggressive maneuver warfare, the Hellcat embodied the American tank destroyer doctrine at its peak. For development of the M18 focused on mobility above all else, engineers stripped away heavy armor to reduce weight, allowing the vehicle to achieve remarkable speeds for an armored vehicle. This made the Hellcat ideal for flanking maneuvers, rapid redeployment, and hit-and-run tactics. The Hellcat was armed with a 76mm gun capable of defeating most German tanks when used effectively. Combined with excellent optics and a fast turret rotation, this allowed Hellcat crews to engage targets quickly and disengage before the enemy could respond. Like the M10, the M18 featured an open-topped turret, improving visibility and situational awareness. However, this also meant that crews were exposed to weather and indirect fire. Survival depended on speed, awareness, and coordination rather than armor protection. The M18 entered combat in 1944 and quickly earned a fearsome reputation among enemy armored units. During the Battle of the Bulge, Hellcat units were instrumental in delaying and disrupting German armored advances, using ambush tactics and superior mobility. One of the Hellcat's most impressive qualities was its mechanical reliability. Even during long advances across Europe, it maintained high operational readiness, allowing U.S. forces to exploit breakthroughs rapidly. After the war, the M18's design philosophy influenced future reconnaissance and light armored vehicles. Its emphasis on speed and flexibility demonstrated that armor does not always need to be thick to be effective. The M18 Hellcat stands as one of the most successful tank destroyers of World War II, remembered for its speed, aggressive tactics, and decisive battlefield impact.